Today we're on Unit 7, Lesson 6, Linear Quadratic Equations. This is an insert. It's a 4 pages, 2 pages stapled back to back. Page 235A and 235B is what we'll be covering with this video. You want to have your calculator, a straight edge, and highlighter. When solving a system of equations algebraically, isolate one variable in the linear equation. Linear is going to be your line. And substitute for it in the quadratic equation. Then solve. Usually there's going to be 2 solutions in this step. Then for each solution, find a corresponding value of the other variable. Remember to find both x and y values. When solving graphically, find and indicate the 1 or 2 points of intersection. If necessary, expand your calculator's window to see all intersections. If there are no intersections, there are no real solutions for the system. Number 1, algebraically solve the system of equations below. Express your answers in simplest a plus bi form. This is our quadratic. The y equals x squared plus x plus 5. And this here is our linear. Y minus x equals 3. Okay, so we're going to get, it'd probably be easiest to get y by itself here. So adding x, we have y equals x plus 3. And now we'll take this x plus 3 and put it in for y in our quadratic. So we have x plus 3 equals x squared plus x plus 5. So we're simply substituting the x plus 3, which is equal to y, in place of the y in our quadratic equation. Now solving, subtract x and subtract 3, we have x squared plus 2 equals 0. The x's drop out. This is an incomplete quadratic, so subtract 2 from both sides, so negative 2 equals x squared. Square root each side, and x equals plus or minus I square root of 2. So when x equals positive I square root of 2, what does y equal? I'll go up back to y equals x plus 3. So y will equal I square root of 2 plus 3. Now, as the ordered pair, our x value is I square root of 2. Our y value, make sure we put this in a plus bi form. Make sure we put this in a plus bi form. So our y value is 3 plus I square root of 2. And when x equals negative I square root of 2, y is going to equal negative I square root of 2 plus 3, which we'll write as 3 minus I square root of 2. So our other non-real solution, negative I square root of 2 is x, and y is 3 minus I square root of 2. So these are our solutions here. They are not real solutions. The 2 graphs of the system can be described as both imaginary. Write one sentence to explain how we can tell by their graphs. Right, so now there looks like we want to graph this. The linear y equals x plus 3, y-intercept of 3, slope of 1. Label it with its equation. And then the parabola y equals x squared plus x plus 5. That has a y-intercept of 5. But we don't know if that's a turning point or what. So grab the calculator, go to y equals, and y equals x squared plus x plus 5. And I might as well put the linear here, x plus 3. So this is going to be a sketch. Green. Get something like this. And since the two graphs do not intersect, that means that their solutions are going to be imaginary. Their graphs do not intersect. So there is no real solution. Right? There's no real solution. As we saw, our solutions are imaginary. Number 2, solve the following system of equations algebraically. Check graphically by sketching their graphs. This is a circle. So this is our quadratic. This is our line. X is already by itself. Y plus 28 equals x. So let's simply take x squared of our circle and replace x with y plus 28. So I have y plus 28 squared plus y squared equals 400. Y plus 28 squared is y plus 28 times y plus 28. So y squared plus 28y plus 28y plus 28 squared, 784. Not an equals. Let's change that to plus y squared equals 400. Combine like terms, 2y squared plus 56y. Plus I'm going to subtract 400, that's 384, equals 0. GCF of 2 times y squared plus 28y plus 192 equals 0. Factors of 192 that sum to 28. Uh, 12 and 16, both negative. No, both positive. 12 and 16. Y plus 12 times y plus 16 times 2 equals 0. Setting each equal to 0. Again, you could skip that and go right to the two values for y if you like. So y equals negative 12 and y equals negative 16. When y is negative 12, What is x? X is negative 12 plus 28 is 16. So when y is negative 12, x is 16. This is the ordered pair 16 comma negative 28. When y is negative 16, negative 16 plus 28 is 12. When y is negative 16, x is 12. Alphabetical, x is first. 12 comma negative 16. So these are our two real solutions. Check graphically by sketching their graphs. Okay, so this here, this is our circle, which has a center 0, 0, and a radius of the square root of 400, which is 20. And this is our line with a y-intercept of 28. Now, if we're using the calculator to check this, but actually before I do go to the calculator, 0 to 200, or rather 20. So let's just say something like this. Here's our circle. This is 20, this is negative 20. And our line has a y-intercept of 28. Be up here. Or sorry, I don't have, our line has a y-intercept of negative 28. And a slope of 1. We must have something similar to this. With our 2 points of intersection. Of 16, negative 12, and 12, negative 16. Let me go back and fix this. I don't know why I wrote negative 28 there. When x is 16, y is negative 12. Now, if you were to put it into the calculator, you would have to get this y by itself, so I would subtract x squared. And then we'd have to take the square root. So y would equal plus or minus the square root of 400 minus x squared. And to put it into the calculator, you would do y1 equals the square root of 400 minus x squared. Y2 equals negative square root of 400 minus x squared. And then y3, we would put the line, getting y by itself, x minus 28. And I'll adjust the window to go from, negative, negative 30 to 30, both x and y. There's one half of our circle, the other half, and then the line. And there are 2 points of intersection there. Why doesn't this look like a circle, more of an oval? It's because this window here is rectangular, not square. Number 3, algebraically solve the system of equations below. Graphically, check graphically using your calculator. Here's our line and our parabola. Let's just make note of that. It's good to know. This is our line, and this is a parabola. So we have our linear equation here, negative 2x plus 1. We've got y by itself. So replace it in for y in our parabola. Negative 2x plus 1 equals negative 2x squared plus 3x plus 1. We always like our leading coefficient to be positive, so I'm going to move all 3 of these terms over to the left-hand side. Add 2x squared, subtract 3x, subtract 1. (2x squared minus 5x equals 0). Factor, there's a GCF of x. Set each factor equal to 0. So x equals 0 and x equals 5/2. When x is 0, what is y? Negative 2 times 0 plus 1, which is 1. And when x is 5/2, y equals negative, going back to the linear, negative 2 times 5/2. It's negative 5 plus 1, which is negative 4. So 0, 1, and 5/2, negative 4. There are 2 solutions. Go to your graphing calculator. Our line, negative 2x plus 1. And our parabola, negative 2x squared plus 3x. I'm going to do a zoom 6. That'll take us back to the standard window. Here's our line and our parabola. And this is going to be a sketch. (0, 1) and 2.5, negative 4. And second trace, number 5, will get us the intersection points. 0, 1, second trace, number 5 again, enter, enter. But for the guess, you have to move the cursor closer to the other point of intersection, 2.5, negative 4. Consider the system of equations below. Here we have a circle and a line. The 2 solutions of the system can be described as, okay, the circle and the line. Well, let's see. For our circle, we have a center of, I don't want to algebraically solve this whole thing, right? So for our circle, we have a center of negative 3, 0, and a radius of the square root of 8, which is equivalent to 2.82. So approximately 2.8. Our line, if I add y, I have 2x equals 4 plus y, and then subtract 4. So y equals 2x minus 4. So I have a line and a circle. The circle has a center of -3, 0, and a radius of just under 3. I'm just going to go out just under 3. In all 4 directions. And try to sketch my circle here. Line, y-intercept -4. Oh, and then a slope of 2. No, this definitely does not even intersect. So the two solutions of the system can be described as both imaginary. Okay, and our last algebraic system, we're going to solve algebraically and then check graphically. Our first equation, our quadratic, is a circle. Might as well pull out the center and radius because we're going to check graphically. So the center is 2, 3, and the radius is the square root of 16, which is 4. And then we have our line. Let's get y by itself. Let's subtract x and add 1. So we'll have y equals -x plus 1. I think I'll actually just go and graph these before we solve algebraically. Y-intercept is 1 for our line, and slope is -1, down 1 over 1. Circle has center 2, 3, and a radius of 4, so from the center, north 4, south 4, there's 1 point of intersection, east and west. Oh, and there's a second point of intersection. -2, 3. And this is 2, -1. Make sure we label our line with its equation. Okay, solving algebraically. Well, we know what we should end up with. We should end up with x values of -2 and +2, and y value of 3 and -1. I'll take this and put it in for y. So x minus 2 squared plus, parentheses, -x plus 1 minus 3 squared equals 16. There are like terms here. There are like terms here. The +1 and -3 combine to be -2. And let's make sure we multiply this out correctly. X minus 2 times x minus 2. X squared minus 2x minus 2x plus 4. Positive x squared plus 2x plus 2x plus 4. Combine like terms. That's out. Plus 8. This is an incomplete quadratic, right? There's no x term, there's no linear term, so I'll subtract 8. divide by 2, and take the square root of both sides. So x equals plus or minus 2. When x equals positive 2, y equals negative x plus 1. Negative 2 plus 1 is negative 1. Two comma negative 1. And when when x equals negative 2, y equals negative 2 plus 1, which is 3. There are two real solutions which match our 2 points of intersection. Thank you very much for your attention today.